Namaste everyone, welcome to Vidhyalakshmi YouTube channel. Myself Moses, I am here as a chemistry teacher. Today's topic is going to be the aromaticity. Okay, the problem with aromaticity with the students is most of the students can't able to identify the given compound is aromatic or non-aromatic or anti-aromatic, right? In this session, right, we are going to discuss what are the conditions makes a compound aromatic, what are the conditions makes a compound anti-aromatic, what are the conditions for non-aromatic compounds also we are going to discuss. After discussing all these conditions, right, we will discuss like with the n number of examples by which we can identify a compound whether it is aromatic or aliphatic, right. Let us see one by one here. Okay, here aromaticity, right, in this one we are going to discuss three kinds of aromatic compounds here: aromatic compounds, anti-aromatic compounds and non-aromatic compounds, right. Let us see some of the conditions by which we can identify a compound is aromatic. The compound is aromatic. The first one is the compound must be cyclic. The compound must be cyclic. It should be a cyclic compound. Okay. The second thing is it should be a planar compound. It should be a planar compound. What do you mean by planar compound? The hybridization for the planar compound, it must be sp2 or sp. We know the geometry of sp2 hybridized carbon is trigonal planar. When it comes to sp hybridized carbon, it is going to be a linear, right? Both are planar only. That's what. First condition is it should be a cyclic compound, and the second condition is it should be a planar compound. It must be the carbons in the cyclic chain should possess what? sp2 or sp hybridization here. Okay, and another one is 4n plus 2 pi electron system. 4n plus 2 pi electron system, right? According to Huckel's rule, the system of the cyclic chain which we are discussing, right, if it possesses the 4n plus 2 pi electron system, it will comes under aromatic compound. For example, here the n might be any integer. N might be any integer. If you take n as 0, you can also take n as 1, n as 2 or n as 3. You can take anything, right? If you substitute n value over there, what we will get? With 4 into 0 plus 2 is equals to, we will get 2 pi electrons. Okay, here by substituting n value as 1 over there, we will get 6 electrons. Here by substituting n value as 2, we will get 10 electrons. By substituting 3 value over there, we will get 14 electrons. 14 electrons. Okay, see here, whatever the system we are calling it as aromatic compound, right, that aromatic should contain either 2 pi electrons or 6 electrons or 10 pi electrons or 14 pi electrons, right. If the compound contains these pi electron numbers, right, then those compounds can be considered as aromatic compound. And the another condition for the aromaticity is the compound should be, what is this? In the compound, complete delocalization should be there. Everywhere there should be a possibility of delocalization, I mean conjugation or resonance also we can consider. Okay, generally these compounds are diamagnetic in nature, but about this we are not going to discuss. Okay, but what are the conditions required for a compound to be aromatic? Those things we have discussed, and let us get into the next one. What do you mean by aromatic compounds here? Aromatic compounds means compound must be cyclic, it should be planar. Planar means the carbon should be sp2 or sp hybridized carbons, and it should contain a 4n plus 2 pi electron system according to Huckel's rule. Complete delocalization should be there, right? When a molecule possesses this particular characteristics, right, then we can consider that particular compound as aromatic compound. For example, let us take what does it mean by anti-aromatic compounds. Anti-aromatic compounds means the characteristics or conditions which we have discussed in the case of aromatic, right? The same conditions will be there in anti-aromatic system also. What is the difference between aromatic and anti-aromatic is, if you see, the first condition is compound must be cyclic. In the case of aromatic also we have discussed compound must be cyclic. It should be planar. Planar means what? It should be sp2 or sp hybridized carbon. Okay, and here the difference between aromatic and anti-aromatic is, in the case of anti-aromatic compound, right, here we will be having 4n pi electron system. In the case of aromatic system, instead of 4n pi electron system, we had 4n plus 2 pi electron system. There is a difference between aromatic and anti-aromatic, right? According to Huckel's rule only, what is this? 4n pi electron system gives the compound is going to be anti-aromatic, right? and complete delocalization should take place for anti-aromatic also. All the conditions for aromatic and anti-aromatic are same, but the difference between anti-aromatic and aromatic is the 4n pi electron system and 4n plus 2 pi electron system in the case of aromatic compound. If you take 4n electron system, right, what we will get? If you take n as any integer 1, 2, 3, 4, we will get 4, 8, 12, 16. These are all the numbers which we will getting as a pi electron number of pi electrons in anti-aromatic, right? In the case of aromatic, we have got numbers called 2, 6, 10, right? Those are all aromatic number. These are all we will consider as anti-aromatic number. Let us see the conditions for non-aromatic. Let us see the conditions for non-aromatic. Non-aromatic means what? We have discussed conditions for aromaticity and we have also discussed conditions for anti-aromatic compounds, right? But here, non-aromatic compounds means compound neither aromatic or anti-aromatic are called what? Are called non-aromatic compound. The compound which won't possess any of these conditions of aromatic or anti-aromatic, those compounds comes under non-aromatic compound. In the case of previous things what we have discussed, the first point was it should be cyclic compound, right? If it is not cyclic, it is aromatic only. Though cyclic compound, if it is not planar, non-aromatic compound. Though it is planar, if it don't possess 4n plus 2 or 4n pi electron system, it is non-aromatic. If it is all is possessing, everything is there, but there is no delocalization, non-aromatic. If compound won't possess like any of those conditions, aromatic conditions or anti-aromatic conditions, those compounds comes under non-aromatic, right? All open chain compounds are non-aromatic. In the case of aromatic and aromatic, we have discussed that what is this? Cyclic compounds, right? In the case of aromatic and anti-aromatic, we have discussed the compound should be cyclic. But if it is an open chain compound, right? All open chain compounds comes under what? Non-aromatic over there. Okay. If you take free radicals, right? Free radical means what? Odd number containing compounds, right? Yes or no? Odd number means in the case of aromatic and anti-aromatic, what we have discussed in the case like with the Huckel's rule, 4n plus 2 pi electron or 4n pi electron system, we have got all even number of electrons, right? If free radical is there, what we will get? Odd number of electrons will be getting with the free radical. That's what all free radical containing compounds are going to be non-aromatic over there. And non-aromatic compounds may be para, may be dia. In the case of this one, what we have discussed in aromatic compounds, generally those compounds are diamagnetic in nature. When you consider anti-aromatic, generally those compounds are paramagnetic in nature. These non-aromatic compounds may be para or diamagnetic in nature. These are the basic conditions of for aromaticity to say any one of the compounds is aromatic or non-aromatic or anti-aromatic. Okay, let us recall the conditions which we have discussed in the case of aromatic, anti-aromatic and non-aromatic, right? What we have discussed in the case of aromaticity, aromatic compound should be cyclic, it should be a cyclic compound and it should be a planar, means the carbon or whatever group atoms are there in the group in the chain, they should possess sp2 or sp hybridization, and 4n plus 2 pi electron system should be there in aromaticity. It means what we call the n might be any integer, right? By substituting the n value as 0, 1, 2, 3, we will get certain numbers like 2, 6, 10, 14 like that. All those numbers are aromatic numbers. Okay, and last one is complete delocalization should be there, right? This is the conditions for the aromaticity, aromatic compound. But when it comes to anti-aromatic compound, right, it should be cyclic, it should be planar, complete delocalization should be there. But only one thing is that 4n pi electron system. If you go with 4n pi electron system, we will get 4 pi electrons or 8 pi electrons or 12 pi electron for anti-aromatic. Okay, but when it comes to non-aromatic, the compound which won't satisfy the condition of aromatic compounds or conditions of anti-aromatic comes under non-aromatic. Okay, all open chain and free radical containing compounds comes under non-aromatic. Okay, non-aromatic may be para or diamagnetic in nature. Okay, these are the conditions for aromatic, non-aromatic and anti-aromatic. Now let us see some of the examples by which we can able to identify the given compound is what we call aromatic or non-aromatic or anti-aromatic. Okay, but only one thing when it comes to aromaticity, right? As we solve n number of compounds, right, means like as we do n number of problems on aromaticity, right, we'll get a clarity about what is aromatic compound and anti-aromatic and non-aromatic compounds. Okay, let us see some of the examples. We have two examples over here. let us identify the given examples as aromatic or non-aromatic or anti-aromatic, right? Now, what is the first condition for aromatic or anti-aromatic? Compound should be cyclic. Yeah, it is in cyclic form only. It is cyclic. Satisfy the condition. What is the second one? It should be planar. It should be planar means what? The carbon which is there in the ring should be what? Sp or sp2 hybridized carbon, right? Let us take these two. Here, this carbon is sp2 hybridized carbon. This carbon is also sp2 hybridized carbon. But this carbon is not sp2, but it is sp3. sp3 means what? It is tetrahedral, right? It is not planar. If it is not planar, then it is going to be what? Non-aromatic compound. What is this compound? Non-aromatic compound, because one of the carbon is not planar. If it is not planar, comes under what? Non-aromatic compound. Now let us see the next one, right? Here, to identify this compound, whether it is aromatic or anti-aromatic or non-aromatic, right? If you remember these conditions, all free radicals comes under non-aromatic compounds, right? If you see here, by seeing this one itself, we can say it is non-aromatic compound. Okay, it is not because of the free radical only we are considering non-aromatic. Here we have what? sp3 hybridized carbon, which are not planar. If they are not planar, comes under non-aromatic, right? Let us go with the next examples. Let us go with the next example. Let us see these examples, by which we can say like whether these compounds are aromatic or non-aromatic, right? We have cyclopropyl and cation is there, right? Cation is there. Now the hybridization of this carbon is sp2. Hybridization of this carbon is sp2. If you see these two carbons, right? If you see these two carbons are sp3 hybridized. sp3 hybridized, not planar. Not planar means what we have to say? Again it is non-aromatic. Non-aromatic. Right. Now let us see this example over here. Okay. What is this? Generally carbene ions are sp3 hybridized, right? Here also it is sp3 hybridized only. Until it participates in the delocalization. If it participates in the delocalization, the carbon is going to be sp2. But there is no possibility of delocalization. That's what this carbon is sp3. And the remaining two also sp3 hybridization only. That's what this is non-aromatic in nature. Non-aromatic compound. Non-aromatic compound. Okay, let us see some other examples here. Let us see some other example. Let us see this example now. Let us see this example now. What is this? We know the hybridization of boron here is sp2 and it has a vacant orbital. Okay, these two carbons are also of what? sp2 hybridization only. In the ring, right? All the atoms, right? Whatever we have, boron, carbon, okay, all are what? sp2 hybridized, means planar. Okay. Means, is there any possibility of delocalization here? Yeah, it is there. Pi vacant orbital delocalization is there. Here delocalization is there. It is a cyclic compound and it is a planar. Well, let us see which kind of rule it is obeying, right? 4n plus 2 pi electron system or 4n pi electron system, right? Now let us take 4n plus 2 pi electron system, right? Pi electrons. If you take n number of 0, as 0 will get 2, as 1 will get 6. As 2 will get 10, like that we will be getting certain numbers, right? Here only one pi bond is there, right? One pi bond means how many number of pi electrons are there? 2 pi electrons are there. 2 pi electrons, right? It is satisfying all the conditions, including this Huckel's rule, right? That's what this particular compound comes under aromatic compound. Aromatic compound. This is what? Aromatic compound. Now let us take this one, right? We can go directly over there. What? All the atoms in the ring, right? All the atoms in the ring are sp3 hybridization. sp3 hybridization. If it is sp3 hybridization, what we can call? They are not planar. If they are not planar, what are they? They are non-planar compound. If they are non-planar compound, they will come under what? Non-aromatic compound. Non-aromatic. Okay. For example, let us take another example here. Let us take another example. Okay. In this one, what do we have? We have 3 carbons here. All the 3 carbons are of sp2 hybridization only. sp2 hybridization only. Here we have a sp2 hybridized carbon. Carbocation is there and one vacant orbital is there, by which delocalization can completely takes place here. Okay. It is a cyclic compound. It's a planar because of all the carbons in the ring is sp2 hybridized ones. and it has a vacant orbital by which complete delocalization takes place. Number of pi electrons are 2 pi electrons are there. 2 pi electrons means it is satisfying 4n plus 2 pi electron system. That's what this compound is. This compound is aromatic. This compound is what? Aromatic in nature. This compound is what? Aromatic in nature. Now let us go to some other examples here. Let us go to some other example. Let us see this one. Let us see this one. Okay. Let me take this one as something like this. Let me take this one also something like this. Okay. Means here we have one pi bond and there also one pi bond, right? Generally, oxygen with 2 single bonds we assume there is a sp3 hybridization. But when this lone pair are connected to the carbon where double bonds are located, right? Then these lone pairs and the pi bonds are in conjugation. Means the hybridization of this oxygen is going to be sp2, not sp3. Means here I have taken double bonds, right, between carbon and carbon. That's what these are also what? sp2 hybridization only. All are planar in nature. All are planar and complete delocalization is taking place. Okay, it is a cyclic compound and number of pi electrons in this one is going to be 2 pi electrons, right? 2 pi electrons. 2 pi electrons means what? Again, we can consider this one as what? Aromatic. This one is aromatic. Let us take this one here. I have kept one double bond over there, right? Okay, here also similar to this one only. When this sulfur lone pair participate in delocalization, formation of double bond takes place, by which we can consider this one as sp2 hybridized one. sp2 hybridized one. And here we know this with the double bonds, right? These 2 carbons are sp2 hybridized only. It's a cyclic one. And what we call a planar, complete delocalization is taking place. And 2 pi electrons are there. 2 pi electrons are there. With 2 pi electrons, what is the what we call formula? It is satisfying 4n plus 2 pi electron system, right? That's what it comes under what? Aromatic. This one is what? Aromatic. Okay. Let us go to the next one here. Let us go to the next example. Okay. Let us take this one. Now let me take this particular thing, right? We have sp2 hybridized carbon, it is a cyclic one, but these 2 are what? These 2 sp3 hybridized carbons. These 2 are what? sp3 hybridized carbon. If they are sp3 hybridized carbon, right, then non-planar. Non-planar means what? Non-aromatic. Right? Let us take this particular compound here with 4 carbons. Here we have 2 sp2 hybridized carbons and we have 2 sp3 hybridized carbons. sp3, if sp3 at least 1 carbon is there, the compound is going to be non-planar. If it is non-planar, then it is non-aromatic. Okay, for example, let us take another one. Let us take something like this compound. This one. Okay, for this one, what do we have? We have sp2 hybridized carbon here and we have sp2 hybridized carbons also here. Okay, delocalization takes place means it takes place. What takes place? Pi delocalization only it is there. It is cyclic compound. Okay, it's a planar. Complete delocalization is taking place. Number of pi electrons in the ring is 2 pi electrons only, right? 2 pi electrons only. That's what? What is this? This compound comes under aromatic compounds. Okay, let us see the next examples here. Let us see this one. Yeah. Now it's a 4-membered ring. Okay. All are sp2 hybridized carbons only. All sp2 hybridized only. It's a cyclic one, planar, right? And complete delocalization takes place. Pi delocalization takes place. We know this one very well. Pi delocalization takes place. Are satisfying all the conditions, right? But which formula it is satisfying? 4n plus 2 or 4n pi electron system? Here in each pi bond we have 2 pi electrons, right? Altogether we have 4 pi electrons. 4 pi electrons means it is satisfying 4n pi electron system. 4n pi electron system is nothing but what? Anti-aromatic. Okay, that is what? This compound is what? Anti-aromatic compound. Now let us take this condition here. Now these three are sp2 hybridized carbons. Only this one is sp3 hybridized carbon here. Okay, though we have 3 sp2 and 1 sp3, right? It is non-planar only. If it is non-planar, It is going to be non-aromatic compound. It is not aromatic. Okay. Now let us go to the next one. Next example. Let us go to the next examples here. Let us see this particular compound here. Okay. We have four-membered cyclic ring here. Okay. We have pi bond and what we call carbocations are also there. All are sp2 hybridized only. All are what? sp2 hybridized only here. Okay. It is planar now. It is cyclic and it is also planar. Okay. And complete delocalization takes place. What delocalization takes place means what we can say? It is a pi cation delocalization is taking place, right? Complete delocalization is there. Cyclic compound and planar. Okay. And number of pi electrons in this one is only one bond is there, right? Only one bond means what? Only 2 pi electrons. 2 pi electrons means what? Which formula it is satisfying? It is satisfying 4n plus 2 pi electron system. Okay. That's what this compound is aromatic compound. This compound is aromatic compound. Okay. For now, let us see this particular compound, right? Generally, carbanions are, let us take carbanions are sp3 hybridized one. sp3 hybridized one. Until it bonds to the carbon with a double bond over there. If the anion containing carbon connected to the carbon with a double bond, right? Then it participates in the double bond, delocalization, and forms what? And forms double bond over there. If it forms a double bond over there, what happens? It is going to be what is this? sp2 hybridized one, right? That's what these carbons are also of same kind. These carbons are also what? Same kind. They can participate in the delocalization. Okay, they can participate in the delocalization. If they are participating in the delocalization, this carbon forms a double bond over there. That's what in this one, all the carbons are sp2 hybridized carbon. sp2 hybridized carbon. It's a cyclic one, it's a planar one, complete delocalization is taking place. That's what this compound is going to be. We can't say it, right? Until we calculate number of pi electrons over there. Here we have 2 electrons, here 2 electrons, here 2 electrons. Altogether 6 pi electrons are there. 6 pi electrons means what? It is satisfying 4n plus 2 pi electron system. 4n plus 2 pi electron system. What is the pi n value here? It is 1. Okay, pi electron system. Okay, this is nothing but we'll get 6 number of pi electrons over there. That's what this particular compound is going to be aromatic compound. Aromatic compound. Okay, why it is aromatic compound means what we have to say? It is cyclic, planar, 4n plus 2 pi electron system it is obeying, and complete delocalization is taking place, because of which we can say this compound is aromatic. Now let us go to the next example. Okay, yeah, let us see this particular example now. Let us see this particular example here. Okay, here these three carbons are sp2 hybridized one, but this carbon alone sp3 hybridized one. If it is sp3 hybridized, as we have already discussed earlier, it is non-planar. If it is non-planar, it is not aromatic, not anti-aromatic. It is going to be not aromatic one. It is going to be what? Non-aromatic. Now let us take this particular compound here. We have 4 carbons here. These 2 carbons are sp2 hybridized one, and these 2 carbons are also sp2 hybridized one. Okay, it is cyclic compound and planar, and hybridization is going to be sp2 over there, and complete delocalization is there. What delocalization is there? Here we can expect pi delocalization. Here we can expect pi delocalization. Okay, that's what it is satisfying all the rules. Okay, let us see how many number of pi electrons are there in the compound. We have only one pi bond in the molecule. That's what we have 2 pi electrons. We have what? Only 2 pi electrons. If only 2 pi electrons means it is satisfying 4n plus 2 pi electron system. Pi electrons. Okay, that's what this compound comes under aromatic category. Aromatic category. Okay, now let us see some other examples. Let us see some other example. Let us see this particular compound. Okay, here as we have already discussed, these 2 carbons are sp2 hybridized one. sp2 hybridized one. If you take this particular nitrogen, right? Nitrogen with 3 single bonds is sp3. Now without any other things, it is sp3. If it is connected to the carbon with a double bond, right? Here delocalization takes place. What delocalization takes place? Lone pair pi electron delocalization takes place and formation of new double bond takes place between nitrogen and carbon. Okay, then the hybridization of this one is sp2. Here, what is there? This lone pair are in conjugation with the pi bond, right? Yes or no? When it participates in the delocalization, what happens? It forms a double bond and also it becomes what? sp2 hybridized. Okay, we have 3 atoms of sp2 hybridized one. But if you take this one, right, it is sp3 hybridized one, sp3 hybridized one. If it is sp3 hybridized one, it is again non-planar, becomes what? Non-aromatic. It is not aromatic. Now let us take this particular example over here. What is this example? Okay, we know this is sp2 hybridized one. Why it is sp2 also we have discussed, and number of pi electrons are there, and we have a cation, right? Cation means what? It is also sp2. All are sp2. All the like 3 carbons are sp2 and nitrogen also sp2. It is planar now. It's a cyclic one. Delocalization takes place. Here 2 kinds of delocalization takes place. One is pi lone pair cation, like pi lone pair delocalization takes place, and pi cation delocalization takes place, and lone pair cation delocalization also takes place. 3 kinds of delocalization is taking place here. Okay, complete delocalization is taking place, cyclic, planar, all the conditions are satisfied, right? But number of delocalizing electrons in the system is 4. Here the lone pairs are 2, and okay, let us see here. Okay, here we have 2 pi electrons and 2 lone pairs and 2 pi electrons, right? Altogether 4 pi electrons are there. 4 pi electrons. 4 pi electrons means what? It is satisfying 4n pi electron system. Okay, 4n pi electrons means what? It is anti-aromatic. Anti-aromatic. Okay, then let us see some other examples now. Okay, let us see these examples right here. Okay, what is the first one? Cyclohexane is there. Hexane itself, all carbons are what? sp3 hybridized one. sp3 hybridized means what? It is non-planar. Non-planar means non-aromatic. Non-aromatic. Right? Now let us take this particular example here. What is this example? We have 2 sp2 hybridized one and 3 sp3 hybridized one. Okay, if at least one sp3 hybridized carbon is there, it is going to be what? Non-aromatic, right? Now we have 3 sp3 and 2 sp2 hybridized carbon, because of which it is non-aromatic. Okay, now let us take this one here. What is this? We have 4 sp2 hybridized one, but only one sp3 hybridized one. If one compound, one atom is there in the cyclic thing, what happens here? It becomes non-planar. If it is non-planar means what? Non-aromatic. Non-aromatic. Let us see some other examples. Let us see these examples now. Here we know these 4 bonds are connected to what? Pi electrons. That's what pi. Only one pi bond over there. That's what. These 4 are sp2 and it is a cation. This is also sp2. It's a cyclic one and what we call planar, because all are sp2 hybridized one, and complete delocalization is there. We have pi delocalization and pi cation delocalization, and satisfying some of the conditions, right? Now let us see how many number of pi electrons are there. We have only 2 pi bonds, right? 2 pi bonds means what? How many pi electrons? 4 pi electrons. 4 pi electrons means what? It is satisfying 4n pi electron system. 4n pi electron system. 4n pi electron system means what? It comes under anti-aromatic. Anti-aromatic. So let us take this one. Okay, generally carbanions are sp3, but when it connected to the carbon with a double bond, right, it participates in the delocalization and forms a double bond, becomes what? sp2. Here all carbons are sp2 hybridized one. All carbons are sp2 hybridized means what? They are planar, right? Cyclic one, planar, delocalization is taking place. 2 kinds of delocalization is taking place. One is pi delocalization, and another one is pi anion delocalization. Okay, complete delocalization is taking place. Okay, it is satisfying certain rules, right? But number of pi electrons, how many number of pi electrons are there? Here we have 2 electrons, here 2 electrons, here 2 electrons. Altogether 6 pi electrons are there. 6 pi electrons are there. 6 pi electrons means what? It is satisfying a rule called 4n plus 2 pi electrons. 4n plus 2 pi electron system comes under aromatic, right? That's what it is, aromatic compound. This is what? Aromatic compound. Now let us say this particular compound, which it will satisfy the right, whether it is aromatic or anti-aromatic or non-aromatic. Here all the carbons have at least one pi bond over here, right? Means all are what? All are sp2 hybridized one. All carbons are sp2 hybridized. The cyclic one, planar one, and complete delocalization also takes place. Pi delocalization takes place. Okay, here also complete delocalization takes place. All the pi bonds are in conjugation. Means what? It is satisfying all the rules. But let us see which formula is applicable. 4n or 4n plus 2 pi electron system. Okay, we have only 4 pi electrons are there. Okay, here 2 electrons, here 2 electrons. Means it is satisfying 4n pi electron system. 4n pi electron system comes under what? Anti-aromatic. That's what this compound is, anti-aromatic compound. The compound is anti-aromatic compound. Let us take another example. Okay, let us take the first one here. Here we have hydrogen also is there. Okay, fine. What do we have? We have 4 carbons with sp2 hybridized one, and boron is also sp2 hybridized, and it has a vacant orbital to accept the pair of electrons. And what is happening? Pi vacant orbital delocalization is taking place, and pi delocalization is also taking place. So 2 kinds of delocalization is happening. It's a cyclic one, planar one, complete delocalization is there, but number of pi electrons are 4 pi electrons are there. Why 4 electrons means? Pi electrons means what you have to say? Because of 2 pi bonds over there, and it is satisfying the formula called 4n pi electron system, right? 4n pi electron system means what do we have to say? It is anti-aromatic. It is anti-aromatic. Okay, now let us take this particular one. What is this one? Here, by seeing a positive charge on the nitrogen, right, we can say it is a sp2 one, but it is not, sorry, sp2 one, but it is not sp2, but it is sp3. Okay, this is what? sp3. Okay, this nitrogen is sp3 hybridized one, and these 4 are sp2 hybridized one. At least one sp3 sp3 hybridized containing what is this atom is there in the cyclic chain. Okay, cyclic one. It is going to be non-planar. If it is non-planar, it is non-aromatic. It is non-aromatic. Now let us take some other examples here. Okay, now see this particular example here. What do we have? We have pi bonds here, and oxygen lone pairs are there in conjugation with pi bonds. Okay, now if you see this particular one, what is this here? What kind of delocalization is there? Pi lone pair conjugation is there, and here in between these two, pi conjugation also there. Pi conjugation is also there. Now by seeing this, right, what is the hybridization of oxygen here? What is the hybridization of oxygen? Generally oxygen, when it is connected to 2 single bonds, right, if it is connected to 2 single bonds means sp3 hybridized. But if sp3 hybridized oxygen with lone pairs or anion connected to the carbon with double bonds means it is sp2 hybridized one. All are sp2 hybridized only now. All are sp2 hybridized only. Complete delocalization is there. Cyclic is there. Planar is there. All the conditions are satisfied. But let us see number of pi electrons. Here we have 2 lone pairs. Here 2. Here 2. Here 2. Altogether 6 pi electrons are there in this system. Let us see with this pi like 6 electrons obeys this one. What is this? 4n plus 2 pi electron system. 4n plus 2 pi electron system means what? It comes under aromatic. That's what the compound is. Aromatic compound. That's what this compound is. Aromatic compound. If you take this one, right? This one and this one both are same only. No difference. Only oxygen atom is here and sulfur atom is over there. And complete delocalization takes place. All are sp2, planar, and everything is there. And 6 pi electron system is there. Follows 4n plus 2 pi electron system. That's what this compound is going to be. Aromatic. This compound is going to be what? Aromatic. Okay. Next, let us see the next slide, next example. Okay, there are certain examples, right? Okay, what are these examples? Which of the following is anti-aromatic? The question is, which of the following is anti-aromatic? Just pause the video for 10 minutes. Just look after all this example, apply all the conditions which I have explained now, and just try to solve the question by your own. Just take 10 seconds. Okay, now let us see which one obeys the conditions of anti-aromatic. Okay, we have first one in which all the carbons are sp3. sp3 means what? Non-planar. Non-planar means non-aromatic, right? In the case of second one, we have two carbons with sp2 hybridized one and one carbon is sp3. At least one sp3 hybridized carbon is there in the ring. It is non-aromatic. Let us take the third one. What do we have? We have all sp2 hybridized one. All sp2 hybridized one. But number of pi electrons is 2 pi electrons are there. 2 pi electrons comes under aromatic, right? That's what it is, aromatic compound. Aromatic compound. But if we take the fourth one, right? All the carbons are sp2 hybridized carbons only. All the carbons are sp2 hybridized carbon, cyclic, planar, and complete delocalization is there. What kind of delocalization? Pi anion delocalization is there. Pi anion delocalization is there, and number of pi electrons are 4 pi electrons are there. 4 pi electrons means what? It is obeying 4n pi electron system. 4n pi electron system. If it is obeying 4n pi electron system means what it is? Anti-aromatic. Anti-aromatic. Okay, that's what. What is the question here? We have to identify the anti-aromatic. That's what the fourth one is, anti-aromatic compound. Okay. Now let us see the another question. Which of the following is aromatic? Okay, which of the compounds means we can find more than one also, right? Let us take the first one. What is this? All these 4 carbons are sp2 hybridized carbon. Here it is sp3 hybridized carbon. sp3 hybridized carbon. sp3 hybridized carbon 1 is there. Then it is going to be what? Non-planar, becomes non-aromatic. Non-aromatic. If you take the second one, now only we have discussed. The nitrogen with the positive charge with 4 bonds is going to be what? sp3 hybridized one becomes non-planar. Becomes what? Non-planar. And remaining all are planar and sp2 hybridized one. If you have at least one atom of sp2 hybridized one, it is going to be non-aromatic. It is again non-aromatic. Okay. Let us take the third one here. The C. Here we have what we call all the atoms in the cyclic compound here are going to be sp2 hybridized. We may get doubt, why can't it be sp3 hybridized, right? Why it is not sp3 hybridized means the lone pairs are in conjugation with the pi bond over there. Okay, when it participates in the delocalization, oxygen forms the pi bond over there. Since it is forming pi bond, it is going to be what? sp2. Remaining all carbons are sp2 hybridized only. Complete delocalization is taking place, cyclic, planar, all the conditions are satisfied, right? Then what is the nature of this compound? This compound, right? We have to count number of pi electrons in the system. 2 plus 2 plus 2 are going to be 6 pi electrons are there. 6 pi electrons means what? It is obeying 4n plus 2 pi electron system. Pi electron system. 4n plus 2 pi electron system comes under aromatic. That's what it is. Aromatic compound. Aromatic compound. Right? Now let us take this one also. Here this one also participating in what? Delocalization. Number of delocalizing pi electrons are going to be 6. Nitrogen is sp2 hybridized 1. That's what it is, planar, cyclic, satisfying all kinds of conditions over there. That's what this is also going to be what? Aromatic. This is also what? Aromatic compound. Okay, what is the question given? Which of the following compounds are aromatic? More than one is there, right? That's what? C and D are the aromatic compounds. C and D are what? Aromatic compounds. Let us see some other things here. Okay, it's a JEE main 2019 question here. JEE mains 2019 question. Let us see which of the following compounds are aromatic. Okay, let us see here. What is the first one here? First one. Similarly, previously only we have discussed, right? We have 2 pi bonds and one lone pair containing nitrogen here. Means this lone pair participates in the delocalization. When it is participating in delocalization, what happens? The hybridization of this nitrogen is also sp2 only. Becomes what? Aromatic compound. 6 pi electrons are there. If you take this one here, all the carbons in the cyclic ring are sp2 hybridized only. But number of delocalizing pi electrons are 4 pi electrons. 4 pi electrons means what? This is not aromatic, but it is anti-aromatic. Let us see the third one here. If you see third one here, what do we have? All carbons are sp2 hybridized one only. Okay, this is a cation one. These are all sp2 hybridized because the pi anion and pi delocalization is taking place. Number of delocalizing pi electrons are 6 pi electrons are there. That's what. This is also aromatic. This is also what? Aromatic. If you take this one, right? This one. If you take this one, right? What is this? Number of delocalizing pi electrons are 6. All are planar in nature, planar in geometry. And what do we have? It's a cyclic, planar, satisfies delocalizing conditions, and number of pi electrons are going to be 6. 6 means what? 4n plus 2 pi electron system, 4n plus 2 pi electron system, right? 4n plus 2 pi electron system. That's what. This is also aromatic. The number of aromatic compounds in this one is A, C, B, D. Okay. Which of the following is anti-aromatic means what? What is the answer? B. But which of the following is aromatic means what? A, C, D is the answer. This is the question from JEE Mains 2019. Let us see another one. Let us take this question. What is the question here? Which of the following chemical system is non-aromatic? How do we have to identify non-aromatic? Okay. Here we have lone pairs on the sulfur. Okay. Benzene is aromatic compound. This is aromatic. We know this one because it is cyclic, planar, complete delocalization is taking place. If you see the B here, this is naphthalene. We have like complete delocalization system, sp2 hybridized one, planar, cyclic one is there. But if you see the third one here, it is aromatic again because of 6 electrons in the system, and sp2 hybridized, planar, cyclic and everything. Here 6 electrons are there, 6 pi electrons. In the case of first one we have 6 pi electrons again here we have 10 pi electrons. Okay, but if you see here that last one we have only 4 sp2 hybridized one, the last one is sp3 hybridized one. If we have at least one sp3 hybridized carbon, it is going to be what? Non-aromatic. That's what according to the question. Okay, according to the question, what is the non-aromatic one? D is the answer. D is the answer. It has come in Karnataka in 2013. Okay, let us see the next one. What is the question here? Which of the compound or compounds out of the following is or not aromatic? Not aromatic. If you see the first one, right? First one is a cyclic one. All the carbons are sp2 hybridized one, planar one, right? Number of delocalizing electrons are 2 pi electrons are there. 2 pi electrons satisfy the aromatic condition. That's what it is, aromatic compound. That's what it is, aromatic compound. Let us see the second one here. Like we have cation here, complete delocalization is there, and what we call complete delocalization is there, cyclic compound is there. A number of pi electrons, delocalizing pi electrons are 4 pi electrons are there. That's what it is, anti-aromatic. Okay. Now let us see the third one. Third one is what? It's a cyclic one. Since anion carbon is connected to the carbon with a double bond, anion is in conjugation with the pi bonds. It's a sp2 hybridized one, cyclic, sp2, planar, complete delocalization is there. Number of delocalizing pi electrons are 8 electrons. 8 electrons satisfies 4n pi electron system. That's what it is, again anti-aromatic. Okay, and let us take the D one over there, right? D is what we have. What is this? 6 sp2 hybridized one, but one sp3 hybridized one is there. If at least one sp3 hybridized one is there, then it is going to be what? Non-aromatic, right? Okay, what is the question has given? Out of following compound, which is not aromatic? Which is aromatic first? A is only aromatic, right? But remaining all are what? Non-aromatic. Sorry, they are not aromatic over there. That's what B, C, D is the answer. That's what A is the answer for this question. This question have come in JEE Mains 2019. Okay, let us see the another thing here. Okay, this is what all about what we call aromaticity, and number of examples we have discussed, and the questions also we have solved, right? The only thing which I can say is, as we practice more and more, right, we will get to know the clarity of the concept, right? as we have already discussed this many examples, right? If you practice all these examples, that is more than enough for your mains and NEET thing, and it is also helpful for board examination also, right? This is all about aromaticity, conditions and the examples, how to identify and all these things. Okay, thank you for watching.